All right, hey you guys, Britt here. Hey, today we're going to do the fourth video in the series on how to understand glazes better, a little more technical aspects of it. And so today is going to be an action-packed day once again. I'm going to do the best I can, and it may take about 40 minutes or something, 45 minutes. So first we should do probably is review what we did last time, and the few times before was we talked about our oxides. This is the unity molecular structure. So we have fluxes, that's the R2O and the RO column. And then we have refractory is R2O3 and the glass former R2O. Okay, and then we also showed how to calculate it so you understand a little about how that is done. So when you go to a Glaze software, you'll have a better understanding of, for instance, if I added alumina, it would not affect the fluxes at all, or silica. And that's a lot of what we're going to be doing today. Another thing we talked about was the Stull Chart, and then how to determine what was a decent glaze. It's not going to be anywhere on here. Some of these are unmelted, some of these are good, and then we talked about limits. And this was Green and Cooper limits. That's about right here. So glazes in this area are pretty likely to be decent glazes at cone 6. This was another cone 6, one of Ron Roy and John Hesselbreath, and they like functional glazes. So that gives you a sort of a ballpark where to have glazes. Okay? So incidentally, I'm not promoting one way or the other. Some people like to use limits, find it valuable. Some people like Stull only, they find it valuable. That's good. And then other people just do the trial and error and ask their friends for glazes and look in Glaze Book. Any of those ways is fine. Okay? So I put these charts up here too from the last one. That was the original Stull chart. This is the one that's on Glazy, and here's with the limits. Okay, so now what we're trying to determine here, we'd like to know how to understand our glazes better and manipulate them using this chart. So what we want to concentrate on is these lines. Now this is alumina increasing, here's silica increasing. And then here's a line 1 to 5, that's alumina to silica. If you have a 1 to 5 ratio, that's going to probably be a semi-matte or pushing towards a matte glaze. 1 to 4 is going to be matte, and that's what this chart shows you. Then this area is going to be under fire, that's probably 1 to 12. This is going to be under fire too. This is going to be presumably crazed. And this middle line is going to be what we're after today, is the 1 to 7.5 line. That's the main glossy line. Now, also remember that you can't assume that this is going to actually show crazing, because that's clay body dependent. And you can't assume this is going to be matte and semi-matte either, because it depends on your firing cycle and cooling cycles. But it may shrink down, it may expand out, all kinds of, you have to be a little flexible in your thinking, but this gives you a generalized idea for most glazes. Okay, so what we're going to try to do today is, the other thing I want to tell you about this is oftentimes in a ratio of 0.3 to 0.7 of these fluxes. So 0.3 of R2O, 0.7 of RO. So that's what Stull used when he developed this chart, and that can vary for certain reasons, and I'm going to show you some ways here with fusion diagrams and with the Daniel Montmillion book. He has a bunch of phase diagrams in there. I'll show you a little bit about that, and we can talk more about that in the next video. Okay, so let me redo this camera orientation here so we can go over here a little better. Okay, so what we're going to do today is I'm going to show you, okay, this is ways to use the Stull Chart to understand and manipulate your glazes. So the first thing we may do when we're using this Stull Chart, we'll type our glaze into Glazing. It's going to give us a plot point. Say it's up here in the matte region, 1 to 5. We predict it's a matte glaze. Now, if we add more silica, we can make that glossy because it moves towards this line. I was telling you this is our gloss line, 1 to 7.5 silica. So if we start at 1 to 5 and we push it this way, it could become more glossy. If we are down below the line here, in order to get to the glossy area, we're going to have to add alumina. That's in the form of kaolin. And so that's counterintuitive. You normally think if a glaze is matte and you add kaolin, it's become more matte. But in this case, it needs more alumina to form the glass correctly. Okay? Another way is if I was down here and I took silica out, I would become more glossy because I'm moving towards that line more. Okay? So those are some of the things we're going to do today. We'll talk about adjusting the ratio of our R2O from say 0.3 and 0.7 to 0.25, 0.75, or 0.2 and 0.8, and that may help us stop crazing. I'll show you phase diagrams and a bunch of other things here, and I have glaze samples to show you, which I think should be helpful for you. All right, so let's get started. I'm going to move this so we can look at what we got going here. So I have all this stuff laid out for you. This is the Stull Chart. I've drawn it here on this board. So here's our silica axis. Here's our alumina axis up here. And then here is some glazes that we have. So like I told you, I took this glaze here, which was a kind of a matte glaze, and I added more alumina. And so as I added alumina, it turns out to be much more glossy. You can see, let me turn these two like this for you. So here is the original one on the left, and then I added more kaolin and it turned real glossy like this. So that's something you can use the Stull Chart to help you understand. Okay? Another thing I did, and you're going to have to imagine it, is I did a progression here where I did less and less silica. I can't find the tiles, but it's basically going to go from this matte to this glossy. And that is on this red glossy line. That's the 1 to 7.5 ratio one. Whoops, I guess I knocked that. So that's where that is. So anything along this line is going to be the best gloss. Okay, I can tell you how I did this too. I took this recipe and I added 2 kaolin and 1 silica and then dipped a tile. 2 kaolin and 1 silica and dipped a tile. And so that's how I progressed up there. All right. Let me see now. I think I'll show you this phase diagram stuff. So what this is, phase diagram is from this book. I have these books here. I have the Parmalee book, and I have the Curry book, and I have this Daniel Mullion book. I'm sorry if I say that wrong. But so in this book, he has a series of diagrams. This is a phase diagram for calcium, silica, and alumina. And in there, you'll have a plot point, or you'll have lines that show melting. So you can see them. They're a lot like topographic lines if you were looking at a mountain. Okay, so in here, then he takes those and he plots those and shows you where the best melting is. Okay, so let me just show you this over here. So he'll take this phase diagram, he'll have a bunch of lines on there, and then he'll pick a certain area. That might be this area here, which I've plotted out for you. It's with this ratio of R2O, RO. And if I am within this line, that's my best melting. This means it doesn't make a good glaze, that's why it just stops. But he has 64 of these in there. Okay, so what that means is when you see this little drawing here, anything in there is going to be good melting, and it's probably going down like deep into a mountain. And so if I looked at it from here, I would see that at the bottom is going to be my best melting, or my eutectic point, and that's where I want to be, somewhere in there. Okay, so now that comports with this, and see, here is our test series are all dotted out right here, and you can see why once they get in there, they get the best melting. Okay? And you see here, I've written down which one this is. It's the 0.4 calcium, 4 magnesium, and 2 sodium potassium. And this thing actually follows the 175 line. Okay? So that's a way of looking at glazes that can help you. Now what I did, I'm going to take some of these off of here so it's a little less confusing. So now what I've got here is I made up some other glazes for you, and I put them on here. So I made up a matte glaze. I'm calling it satin or matte. It's called John's Satin, and here's John's Matte 3, John's Matte 1112, etc. And these are over here. Okay? And then this last one here is one of Hansen's matte glazes. And you can see it doesn't really match up with the line. It's close, but here's where they are. So I took them, and so here's my original glaze, the Hansen. It's pretty matte. See if I can focus. It's hard to focus on a matte. Anyway, so there it is, and then I'm going to show you, like as I come down here, you can see the glossy shininess. It gets glossy, 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 and then it's unmelted here. So I think you can see that, like it's, let's see if I can do it this way. See how it's pebbled? So that's probably too much silica. What I did was I added silica 1% to 12. And so now what I may decide, hey, I like the matte, but I'd really like it to be satiny matte. So maybe this is the spot that I like. And maybe that's, now I'm going to retotal my recipe with 5% silica in there. Okay, just in case you're interested, here is the recipe, Hansen. And here is the unity molecular. You can see that my magnesium is 0.4, my calcium is 5.4, and then this is my R2O. Here's my ratio. Here's my ratio of fluxes. Okay, so then I made up some more glazes, and then what I also do is I'll put India ink on them so I can see if they're crazing and stuff. So this one was John's Matte 1112, and I did a cone 6 fast fire. Here's the ingredients, and here's the unity molecular. So this is a 0.3 to 0.7, a 1 to 4.6. There's some boron in there, about 0.15. And you can see that this crazes, and then as I add silica, it stops crazing and gets more glossy. So like if I held this one next to this one, and you can see like this is more glossy. See the shine on there? And it's not crazing either. So you may decide, hey, somewhere in here is the gloss that I'm wanting with my firing cycle. And then I'm going to add like 7% more silica to this recipe and then retotal it. All right, so I did a couple more of this, and we don't need to beat the dead horse, but look, this one didn't craze. Here's the recipe, and I don't know if these are great recipes. I just made them up. They're pretty high in kaolin, but they work pretty well. Sometimes you have to calcine that. And this one, I cut down this was a 0.3 to 0.7. And this one is 0.23 to 0.77. So I reduced some of the sodium in favor of calcium, so that stopped the crazing. Okay, then my last one, and you can see sometimes with matte glazes you get, when I rub the India ink in there, it gets into the pock marks of a matte glaze, and it stays in there, so that might cutlery mark. But some of these other ones are going to be good. Here's a little bit more of that. You can see here when I put the India ink on, it was all matte until there and pocky until about right here. And this is this recipe. It's also got a lot of EPK in it, but this one I traded some of the calcium for magnesium, and that gives you satin matte colors. Okay? So that may have been one of the reasons this one didn't craze as much, because magnesium has a low expansion, sodium has high. And so this is a 0.26 to 0.74. Okay? And I did one of these diagrams for you, and you can see this is what our ratio of flux is, and this is where these tiles all are, right in the center of this best melting point. Okay? Just so you know that in my book, the High Fire Glaze book, I tried to put these similar diagrams in, but without being too complex. I showed you where magnesium mattes would be. That would be the 1 to 5 line. This would be 1 to 12. That's best melting, etc., etc. And we'll talk a little bit more about that when we get into this book a little, because he has recommendations for the amount of fluxes and type of fluxes for, say, a khaki or a oil spot. Okay? So the next thing that you may want to do when you're doing glazes is then to add colorants. So what I did, just pretend just pretend this is the Handsome recipe. It's actually called 3M4. It's in my book, the mid-range book, and it's very close to Hansen, so that's why I was just using it, because I had these tiles. But you can see when I add silica to this, and I have 8% Mason Stain 6600 black in here. So I wanted to have a black that was not completely matte, but satiny. So I kept adding silica. I believe it was 12%. And here is my final tiles. And you can see how that's kind of glossy compared to how matte this one is. That's like super, super matte. Okay, so you can go in there and pick wherever you think is good. Now the trouble is with stains is you don't know what's in a stain because it's proprietary. But you have a pretty good idea that we're going to be moving from here towards our gloss line. When you add stains, it might jump it up a little bit because there's alumina and silica in stains. All right, and I did the same thing here with John's Matte 1111, and I, some of these are really nice satiny mattes. Okay. Now another thing that I did here was I took that Hansen base or the 3M4 base, and I added colorants to it. And I don't really think you need to know exactly what the colorants are, even though they're listed here. The main thing is to get the overall view of this, that they're kind of dull colors. They're not super bright. This is because it's a high alumina base, and alumina gives you dull colors. So that is the situation there. Okay, now this one is an example of Ashley's Best. Do you see how this is somewhat glossy? It's trying to be glossy at cone 6 on the tip there. And then as I add silica to 20%, it becomes very matte. And so that is an example. Here is where the Ashley's Best is. And as I move across here, you can see I'm going to go into the under fired range. So it's not going to become, it's glossy here, and then the more silica I add, the more matte it will become. Okay, let's see what other stuff I got. I was going to show you, these were, okay, so then now we're going to talk a little bit about firing. So not only is there unity molecular and chemistry involved, there's also firing. So these were fired to cone 6, so were these. This shows clay body variation. Pretty close, but a little bit different in tone. And then this one I fired to cone 8. So that just shows you the difference. Firing hotter. Hotter will melt it more. So we don't get as much purple, we get more glossy blue. Okay? All right, wow, I think I might have achieved that. All right, so the other thing I want to talk about before we're done is this shows that how a clay body matters in a glaze. So here is a glaze called Seltzer Chun 2 with 0.5 iron at cone 6, and E1 is fast fire. And you can see how it looks like there's 4 different glaze recipes. But in fact, it's one recipe on a different body. And you can see the major difference that the clay body makes, especially in terms of, say, crazing there, or pinholing and all this color. Okay, so clay body makes a huge difference. Here's an example of firing variation. So this was in an article I wrote called Experiments in Peach Bloom. You can Google it. And I took 5 clay bodies, 5 firings is what I varied. The Glazes Jeff's Red, cone 10. This was cone 6. This is cone 10. And what I did was I dipped them all the same, but I fired this one in wood, this one in high reduction, this one in reduction from 08 to cone 11. This one was striking. And so it doesn't really matter all the details of that, but what you want to see is it looks like 5 different glazes, but it's the same glaze. Okay, here's another example. This is splotchy lavender, similar colorant variation. All right, and another thing I wanted to show you was, like, this is a cooling variation. So it wasn't they were both in oxidation, E1. That's fast fire, cone 6. And so this is Ashley's Ash. It's in the book, and I added titanium and iron, and that was just a straight cool. This one I cooled for 2 hours at 1800, and you can see how this one becomes very satiny, and this one's pretty glossy. Okay, so that is going to matter to your pieces. Let me see what we have forgotten. Have we gotten everything? So we can add more silica, makes it more glossy and less crazing. We can add less silica, it makes it more glossy. More silica can also make it more matte. Adding alumina, following the line up. Phase diagrams, color response. Okay, I think we got everything. That was miraculous. All right, well, thanks for listening, and I hope it helped you a little, and I will see you next time.